So in chemistry and in physics, what we've done is we've looked at atomic structure, and I'm going to go through it again, and I'm going to go step by step, and we're going to have a look at what is called ionization. So I'm going to start off with something you do not see on the periodic table, and it was one of the isotopes I talked about last week, which is H2O. This is hydrogen. And normally hydrogen looks like this on your periodic table, H11, but this is weird. There's 2 at the top, then 1. This is what we call an isotope, and we looked at them last week. So I'm going to talk you through again what we looked at, but that's not part of today's lesson, but it leads on to it. So this is the bottom number there tells us how many protons we have. Protons are found in the nucleus, in the center. This is 1 proton, but that's exactly the same number of electrons. Electrons are smaller and whiz round the outside. To work out the number of neutrons, you do the top number, 2, minus 1. You're not doing any of that today. And that doesn't mean I've got 1 neutron. And neutrons are found in the center. Okay. If an isotope has too many neutrons, or not enough neutrons, or is too big, it's unstable. All right. And what it does, it emits radiation. And I'm sure most of you have heard of radiation. And next week we'll look at the different types of radiation. So it emits unstable atoms. What they do is they decay. That means they break down. All right. And they emit, which means they give off. They give off radiation. Right. So this is what I want to talk about, radiation, because there's 2 types. Okay. The first type of radiation is I'm sat next to the log burner and oh my God, it feels so nice. I've been out in the morning and oh my God, it was so cold. I was out with them, it's not cold. So the type of radiation I'm talking about there, I'm sat next to the log burner, is heat. Or let's be very technical, infrared radiation. Right? This has got nothing to do with what we're doing today. And this is the weird thing about physics. We can talk about different things using the same word. So radiation, I am not talking about it gives off radiation, the type that I'm sat next to a radiator and a radiator radiates heat. No. I am talking about the kind of radiation that you read about in superhero comics, like gamma radiation that the Hulk was exposed to. So there's gamma radiation, there's alpha radiation. I've put it in the wrong order simply because I thought I'd start off with the Hulk. Alpha, beta, and gamma. And these are the different symbols, and you'll get used to them. Okay? Alpha, beta, and gamma. We're going to do alpha, beta, and gamma, but gamma first because we can talk about the Hulk. So the radiation I'm talking about that isotopes give off, we are talking about these 3. And we'll look at them in more detail next week. But I really, really want to iterate that today what I'm going to talk about is this radiation is ionizing. Right? And I really want to talk about this word here. What do we mean? So the whole lesson today is based off of this. All right? What do we mean? Let's make this huge. What do we mean by ionizing? All right? So the entire lesson today is answering this question. What do we mean by ionizing? So what I've put up here is an image of an atom. Well, we've got 1, 2, 3 protons. This is lithium. Right? 4, 3, 7, 4, 7, 3. Although it should have 4 neutrons, 1, 2, 3, 4. It doesn't. Anyway, so this looks like, well, this is lithium. This is an isotope of lithium. Anywho, what do I mean by ionizing? Well, as I just went through what we did last time, an atom has protons and neutrons in the center and electrons whizzing around the outside. And ionizing means, doesn't matter which I'm looking at, doesn't matter if it's alpha, beta, or gamma. It comes through and it knocks one of the electrons off. The electron goes bye-bye, and it knocks the electron flying. That's what I mean by ionizing. Okay, so if it loses an electron, it becomes a positive ion, right? And what is a positive ion? If an atom loses one or more electrons, the atom becomes positively charged, right? And you no longer call it an atom. You can't go, oh, look, there's a hydrogen atom. No, you knocked off an electron. It became positively charged. It is no longer an atom. It is an ion. This is not iron. When I was young, I used to get confused by this. It's like, well, hold on. This is iron, the metal. No. All right. If I take hydrogen, my atom with one electron, and I knock this electron, I've got bye-bye. You are left with a positively charged hydrogen ion, not iron. There's no R in it. Okay. Now, why does it become positive? Well, electrons, if you remember both from chemistry from last week, are negatively charged, right? The nucleus is, especially in hydrogen, is one positive. They cancel each other out. So in an atom, the number of protons, which are positive, is equal to the number of electrons. That's why I pick hydrogen, because it's easier to think about. So all of a sudden, I go, bang, knock that electron off. Then what I'm left with is a proton all by itself with no electron. And look, it's positive, right? So if an atom loses an electron, it loses negative charge. So overall, it becomes positive because you've got more protons than electrons. Yeah? Okay, how do atoms lose electrons? One of my favourite is static electricity. So when you get something and rub it sometimes, you can get a balloon. It's really good to get a balloon. Rub it on yourself. You're actually rubbing off electrons and you get static electricity built up and it will pick pieces of paper off. It'll stick to the ceiling in certain conditions. Another is light, right? So light is electromagnetic radiation. Don't worry about that. But this is part of that is light, okay? And another part of that is gamma radiation. If you shine strong enough light of the right frequency, not intensity, frequency, that's a different story, you will knock an electron off. The other way is chemical reactions, right? That's how you form positive ions. Ionization means removing electrons from an atom. This is very different. This is high energy radiation, which I said was alpha, beta, or if you're the Hulk, gamma. If any of that radiation goes near an atom, it can knock an electron off. And that is what we mean by it is ionized and it's overall positively charged. All right. So are ions reactive? Yeah. Because they're positively charged, they can rip off, they can pull electrons from other atoms off, right? But it all depends on the type of atom. All right, so you've got 10 easy questions. I've gone through it. It's taken me just under 9 minutes. I'll convert this. So if you were late, I know a couple of people were late, you can go through the intro again. All right, darlings, that was fun. I quite enjoyed that. I'm going to stop this recording.